What's Gucci, everybody? And in this 10th video, I'm going to be talking about Boolean operators. Now, in a few videos ago, I showed you about the if statement that looked at if the statement above was true or false, and based on that, printed out a statement, or did what was in the block, or did not execute what was in the block. Now, I showed you how to write an if statement to check if I is equal to 5. Remember, double equal signs is a comparator operator. It compares these two values, and the equal sign is an assignment operator, so it assigns the values. So if I equals 5, I'm going to print f. Let's print out I. And I'm going to run this, and it's going to print out 5. Now, what if, let's say, I didn't just want to check if I was equal to 5. I wanted to check if j was equal to 10. So I would need to check if I is equal to 5 and j is equal to 10. How would I do that? Well, it turns out there is an AND operator. It's 2 ampersands, not 1 ampersand, not 3 ampersands, exactly 2 ampersands. And this is the AND operator, not to be confused with a single ampersand, which was a bit operator, which would check if there were 2 ones in the bits for binary. As you can see, these are reused. And so what this does is it checks if if I equals 5 and j equals 10, it will print out 5. So it only works if both of them are true. If I is true, if I equals 5 is true, and j equals 10 is true. If one of them is wrong, it will not print out. And as you can see here, nothing is printing out. Now, what if, for instance, I wanted to know if just one of the conditions is right? So, for instance, this is AND. This requires both conditions right for it to be true, and anything else, it will be false. So if only one of them is true, then the whole thing is false. And if none of them are true, then it's false. But what if I wanted to execute what was in this block if just one of them was true? Then I would just use an OR statement. This is using double, column lines, I like to call them. It's right above your enter key, I believe, on most keyboards. And what this is an OR statement. Note again, it's two pipelines. I guess that's what you call them, is pipelines. And instead of one, which is because the bit symbols use only one. So now what we're going to do is we're going to look at this statement again, and it's going to say if I is equal to 5 or j is equal to 10, print I. So it was true, obviously, because I is equal to 5. That's true. We don't even need to look at this other part of the statement because we already know one part is true. So it's going to evaluate this statement to true because it's an OR statement. So if it equals this or it equals that, so either of them will activate it. Either of them will evaluate the statement to be true. Now, if both of them are true, that's good. But the OR statement is just looking for one, so it returns true if one of them is true, if the other one is true, or if both of them are true. The only instance where it doesn't return true is if they're both false. For instance, in this scenario, when I change this to 7, as you can see, nothing is being printed out when I run the program. Another operation that I want to show you is the less than or equal to operator. So let's say I wanted to compare values, and I wanted to see if I is greater than j. So if I is greater than j, which is saying if 7 is greater than 11, which it's not, print this statement out. And if I run this, it's not going to work. So as you can see, this is basic math. Hopefully you know some algebra, and you can easily evaluate this statement. Now, if I switch this around to check if I is less than j, which is true, this statement will evaluate the true and execute the code in the block, it will print out I, which is 7. And something I can also do is these are the greater than and less than symbols. What I can also do is I can do a greater than equal to symbol, which just checks if it's greater than or equal to. So if I made these both 7, it will evaluate to true because it's not greater than, but it is equal to. And the equal to must come after the greater than symbol. I can't have the equal to before this, or else I'll get a compiler error. Yeah, see, there's an error. It exists in my project. I must have the equal after this. And note I can change the symbols around if I want to. And if I run this again, the error symbol will disappear. And hey, I get 7. So, yeah. Is that all the operations? I believe so. There was no inclusive OR like in binary. In binary, there's a symbol with a caret top. That's inclusive OR. There was no double inclusive OR. There's just the greater than or equal to symbols. And that's about it today. You can do a lot of damage with those. Remember, you can also do the not equals. So this is just checking that J and I are not equal to each other. Oh, geez, my YouTube video loaded. Sorry, guys. This is checking if they're not equal to each other. It's good to have some chaos, I guess, in my videos, except when you're teaching, because people need to learn these things. And as you can see, I just clicked it twice, and it's not running because they are not equal to each other. So the not exclamation mark reverses an equal statement. So this says if I is equal to J, but this is checking that I is not equal to J. Basically, the exclamation mark symbol stands for not in Boolean language. Well, guys, I hope you liked this video, and that's going to be all for today.